Alright, here's a nice big triangle right here. Looks just like an acute triangle. Nothing real special about it. It's not a right triangle. It's not obtuse or anything. It's just a regular triangle. We could do this with all three types of triangles. I don't have time to do it with all three of them. If you look on page 324, they actually do what we're going to do with all three types of triangles: an acute, a right, and obtuse. Alright? I just picked this one. This is what we're going to do. We're going to find a thing called the circumcenter. Circumcenter. Now, there's several different new words that you're going to learn, okay, and it's kind of hard to keep them straight. This is the first one that we're going to learn, all right? So you might want to make a list of these things. This is the first major word we're going to learn. In the next section, we're going to learn a couple, well, actually, the second half of this section, we're going to learn a couple more. But on this one, in order to find the circumcenter is a point. It's a point of intersection. It's a point of intersection by three concurrent lines. What does that mean? There are three lines that intersect each other at that common point, all right? But what we're going to do in order to find the circumcenter, what we do is all three sides, we find the perpendicular bisector of all three sides of, we'll just say this, of the sides of the triangle. Okay? We'll call this A, B, C. So what we're going to do is we're going to find the perpendicular bisector of all three sides. So let's use red on this one. So first thing we need to do is we need to find the midpoint. We're just going to have to eyeball this. I don't really have a ruler. I guess if I had some kind of a ruler thing, we could figure it out. But help me out on this. I'm not good at finding the midpoint. Where's the midpoint?
Right there.
Right there?
Yeah.
Okay. So there's a midpoint here. Now, I want to find the perpendicular bisector. So why did I find the midpoint? I found the midpoint so that I could do the bisector, correct? Now I got to do a perpendicular bisector. So I go from this, and I go perpendicular. And that would be right there. Now you could take this all the way up if you wanted to. I'm just going to take it to the other side of the triangle. Alright, so there's a perpendicular bisector. We'll put a little right angle thing here. That's being bisected. We'll say that and that are equal. Now we are eyeballing a little bit, so when we get to the third one, we may have to fudge just a little bit. All right, but if I had a ruler and I was making sure everything was perfect, it should work just fine. All right, so we took BC. We found the perpendicular bisector of BC. You with me? Let's take another side. Let's take AB and let's find the perpendicular bisector. So first thing we do is find the midpoint. Stop me when you see the midpoint. Right there is good? No? Up, down? Right there? Okay, wow. For some reason, I cannot just... To me, the midpoint looks about right in there, but I'll trust you guys. You got it right before. All right, so now we got to go perpendicular. Now I got to eyeball this again. Tell me, where do you think perpendicular is? Maybe about right there. So we'll take this way up. Does that look pretty close to perpendicular? Pretty close. All right. Again, I'm just eyeballing it. All right, so it's perpendicular, and these two sides are equal to each other. Would you agree? All right. Now here's the one that I'm going to have to maybe fudge just a little bit. Where do you think the midpoint is here? Tell me when.
Right there.
Right there? Okay. Wow, that's not going to be even close. No, that's not the midpoint. I'd say the midpoint is... I'd say the midpoint's about right there. Told you I got to fudge a little bit on this, all right? So, now look, if I had a ruler... Yeah, that might be off even a little bit. Now watch. Oh, actually, I'm sorry. Yeah, I'm sorry. I was thinking of something completely different. I was thinking of a. I was thinking of a median, and we'll talk about that a little bit later. All right. So where do you say the midpoint is?
Right there.
Right there. Okay, I'll trust you. All right. So now we got to go perpendicular, right? So what I'm going to do? Where's perpendicular? Now look at this. If I go perpendicular, now again, I'm eyeballing just a little bit. Okay. Nah, it's close enough. All right, we're going to say that's perpendicular. All right. If that's perpendicular, then, well, it's off just a tad. Let me... Yeah, if I draw a big dot, you can't tell the difference. I'd say about right there. That's good enough. Okay? So watch. This point right here It's a concurrent line. So if we did that, now again, if you were really careful, used a protractor to find 90 degrees, if you used a ruler to find the midpoints and all that kind of stuff, then it would work out nice and perfect. We just kind of eyeballed a little bit, and that's why it might not be dead on exact, but it's pretty close. It's pretty close. So what do we do here? We made this side equal to this side because that was bisector, and we made it perpendicular. Now, see this point right there? What do you think that point is called? The circumcenter. Okay, that's called the circumcenter of this triangle. Now, what's interesting about the circumcenter is this. Let's go a different color. If I took this point right here and I connected it to the three vertices of the triangle, so I'll tell you what, let's call this point P for point. If I connected from P to what? The three vertices, B, and I connected from P to what? C, right? And I connected from P to what? A. See all three of those blue lines right there? They should all be equal to each other. If this is the circumcenter, then it's equidistant from the vertices of the triangle. That one's not quite hitting that vertex. That bugs me just a little bit. There we go. That's a little bit better. Okay? You understand that? So, if P is, let's write it like this. If P is the circumcenter, then what must be true then? AP must equal what? BP, which must also equal what? CP. Do you see it? All right, if that's the circumcenter. Again, how do we find the circumcenter? We find the circumcenter by finding the perpendicular bisectors of all three sides of the triangle. Does that make sense to you? Mm-hmm. Now, we're going to be doing this like 3 more times, but it'll be very similar to this, but it's going to be hard to keep them straight. So study this tonight. Go through it. There are a few problems you have to do something about the circumcenter, okay? So remember what we've done right here, and let me give you some problems to work on tonight. And then we'll finish up section 5.1 tomorrow. Let's see. So we're doing call it 5.1a. All right. So when you write it down on your paper, put 5.1a because tomorrow will be B. And it's page 327. And we're going to do 9 to 20. Now there's a couple word problems in there, but don't let those things, you know, scare you off. It's really not that big of a deal. They just draw some pictures, but it's the same kind of thing, except they try to make it look like real life kind of stuff. But it's the same kind of stuff that we've been doing on here. You'll see what I'm talking about when you get to it. All right, so it's page 327, and we're doing 9 to 20, section 5.1a. See you tomorrow.